tutorial we are going to teach about semiconductor. The topics we are going to cover in this video are: in which basis we are going to divide the material, what is a semiconductor, classification of semiconductor, and some details about P and N-type semiconductor which are very important. So the basic thing depending on which we can divide any material is nothing but its band energy diagram. We all know about valence band and conduction band. There is a certain energy gap between these two bands, which makes the difference. As we can see from the energy band diagram that in case of conductor, valence band and conduction bands overlapped each other. But in case of insulator there is a huge energy gap between valence band and conduction band. So in case of conductor, electrons can easily jump from valence band to conduction band due to which conductivity generates. But this is very tough to jump from valence band to conduction band in case of insulator. And semiconductor is just the state in between conductor and insulator. The energy gap is lesser than insulator. As a result there is a chance of jumping from one band to another, which can generate conductivity. Now simply we can say that substance which has conductivity lies between conductor and insulator are called semiconductor. Examples are silicon and germanium. Some important points regarding semiconductor which we should know are: first of all, the energy gap between conduction band and valence band is less. The very small energy required to move the electron from valence band to conduction band. At low temperature means at 0 Kelvin the valence band is completely full and conduction band is completely blank. So at this situation semiconductor virtually behaves as an insulator. At room temperature, some electron moves to the conduction band due to which conductivity increases. As temperature increases, more number of electron moves to the conduction band and conductivity increases. As in semiconductor, conductivity increases with increasing temperature, it shows negative temperature coefficient of resistance. These semiconductors are basically divided into extrinsic semiconductor and intrinsic semiconductor. First of all, we are going to discuss about intrinsic semiconductors. This is the pure semiconductor. As for example simply silicon and germanium. From the diagram we can see in case of silicon whose electronic configuration is 1s2 2s2 2p6 3s2 3p2. Means 4 valence electrons are present in valence shell. The semiconductor bands are formed by sharing electrons. Such bonds are called as covalent bonds. Electrons are bounded with each other, that's why they are not available for conduction in absence of any thermal excitation. Hence at 0 K semiconductors act as an insulator. At 250 C some bonds get enough energy to break their bonds and become free electron. The energy required to break the bond are 0.72 electron volt for germanium and 1.1 electron volt for silicon. The valency created by breaking of bonds represented by tiny hole, and these are called as holes. This valency can be filled up by another electron, so the movement of holes are opposite to the movement of electron. For an intrinsic material, number of holes are equal to the number of electrons. There is no net charge in these materials. Now come to extrinsic semiconductors. These are the impure form of semiconductor, means we add something form outside to increase the conductivity of an intrinsic semiconductor. The process of adding impurity is called as doping, and the impurity which is being added is called dopant. Two types of doping is possible: acceptor doping and donor doping. Acceptor doping makes holes and donor doping makes electrons in the valence band. Based on the type of doping, these materials are further divided into two categories: N-type semiconductor and P-type semiconductor. So let's discuss one by one. First we are going to discuss about N-type material. Group 5 elements means pentavalent or having 5 valence electron in valence electron like phosphorus, arsenic, added with pure semiconductor. So when we are adding these kind of impurity with silicon or germanium, 4 electrons are making bonds with other parent silicon atoms. But they have one more electron extra. These extra electrons further make a donor level in the band diagram. After releasing free electrons, the impurity atoms become positively charged immobile atoms. As they are donating electrons, they are called as donor atoms. So, these extra electrons can move from valence band to conduction band, making holes in the valence band. This process is called as band-to-band transition. In case of N-type of materials, majority carriers are electrons and the minority carriers are holes. So the current will cause due to both majority and minority carriers. Now in case of P-type semiconductors, group 3 elements means trivalent atoms like aluminium, boron, indium, gallium are added as impurity. So when we are adding this kind of impurities with a intrinsic material, the available 3 electrons are making covalent bond with germanium atom. But at the same time a vacancy is creating. This vacancy is nothing but hole. These vacancy can accept electrons, so they will further form a acceptor level. So as a result the electron from the surrounding atoms will try to fill up this vacancy. As a result electron flow will start as well as conduction occurs. And in this case majority carriers are holes and minority carriers are electrons. But one thing we have to remember that both N and P-type semiconductors are electrically neutral. With this we are finishing. So friends, if you have any doubt, comment in the comment section, and for more subscribe our channel.